countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum. Good evening and hi to all teachers, parents and wonderful students. So welcome to Pusat Tuisyen Academy YouTuber, a joint venture with Didik Malaysia and Kelab Guru Malaysia with the hashtag bermula percuma and selamanya percuma. So before we proceed, let's begin our session with the recitation of Kitab Al-Fatihah, and for the non-Muslim, please take a moment of silence. Okay, so how is everyone doing today? Okay, I pray that everyone is in the best of health and ready to proceed with today's class. So let me introduce myself. So I am Madam Rosmaya from SMJK Yuhua Kajang Selangor, and today I will present alone because my partner Madam Nun cannot join us today. And before we start our discussion today, so please subscribe to my channel so that you won't miss any of the new video in the future. And as usual, the lesson will last approximately about 1 hour, and the certificate link and the credit claim link will be given at the end of this session. And you can only use the email and more email to claim the certificate. So I will put the link to apply the EDD email in the chat box. Okay. Okay, hi Chiayao. Okay, I can see your message there. Okay, so be sure to follow the class up until the end and give your full cooperation in making this session a lively one. Hi, Alden. Okay, I will also like to remind students to use appropriate language and also use appropriate profile picture if you wish to post comments in the chat box. So I'm pretty sure all of the students here are excellent students who will uphold a positive classroom environment. So stay focused, and if you have any question, you can write in the chat box because we are going to discuss today our final revision for the STPM. STPM is coming next week. Okay, I wish you all good luck. Okay, hi Chiayao, Madam Non. Madam Non cannot join us today, but next week she will join us. Okay, so without further ado, I will announce now the first letter and together with the 2-digit codes for the credit claim. So the code is A number 33. Okay, A, letter A, 33. Okay, so now I'm going to open my slide. Okay, so before we start, I'm going to, as usual, to introduce my team. Okay, the UPU team in the Academy YouTuber. Okay, so we have this is physics team. Okay, lead by me. Okay, and we have teacher Su, teacher Absayu, and also teacher Nun. Okay, in our team. Okay, in the mathematics team, lead by teacher Im. Okay, biology pre-U team lead by Cikgu Faiza, and chemistry pre-U team lead by Cikgu Shahnon, and perkaunan and economy pre-U team lead by Madam Fizi. Okay, so we also have Academy YouTuber apps. Okay, you can download from the Google Play Store, and there's a lot of video there, not just our video, physics video, but also other videos. Okay, and then okay, so now we have come to the main objective today. Okay, so we are going to discuss on semester 2. So I choose a few questions to be discussed and posted already in the Google in the description below. Okay, and also in the comment chat box. You can download from there the question. Okay, so let's start now. Okay, so let's read the first question together. And if you have managed to answer the question, you can write there in the chat box the answer for the question. Okay, so now question number 1. A spherical surface of radius r containing charges negative 2q plus 3q plus 4 positive 4q is shown in the diagram below. So what is the total electric flux which passes through the spherical surface? So the spherical surface here is called Gaussian surface. Okay, and we are going to use the Gauss law. So can you all remember the Gauss law? Okay, this is Gauss law. So it states that magnetic flux is equals to the total of charge divided by epsilon naught. Epsilon naught is the permittivity of free space. Okay, so how many charge we have here? We have 3 charges. So we total them up: negative q plus 3q and plus positive 4q, and divided by epsilon naught. So the permittivity of free surface value is 8.85 times 10 to the power of negative 12, and you will get the answer here is in terms of epsilon naught. So your total is 5q per epsilon naught. The answer is C. Okay, so what about your answer? Is it same with me? Okay, if you got same answer, then very good. Okay, so memorize this Gauss law. Remember, formula is not given in the exam. Okay, by right now you should memorize all the equations already, formulas already. Okay, Pavitara, you got C answer. Okay, correct. Okay, now question 2. Okay, if you all got the answer already, you can write there. Okay, and those who got wrong, so do you know where you've gone wrong? Okay, hopefully you know. Okay, so next question number 2. A proton enters a uniform electric field at M and moves in a parabolic path to N as shown in the diagram below. Okay, if the electric field strength is 600 volt per meter, so what is the change in kinetic energy of the proton? Okay, so look at the proton here. Okay, so it moves in this direction. Okay, given direction that as shown in the diagram. So but in the data given in the question is the electric field 600 volt per meter, and the question wants change in kinetic energy of the proton. So for change in kinetic energy, so the word change in means what? It's mean final kinetic energy minus initial kinetic energy. But in this question, the velocity is not given, so you cannot use this formula. Okay, but we can use another formula. Okay, from the work energy theorem that you've learned in chapter 1, in Sem 1. Okay, chapter 4, if I'm not mistaken. Okay, so we can relate change in kinetic as a work done. So the work done, we can use F dot S. Okay, the product, not the product, the F dot S. Okay, so the product lah, dot product. Okay, so F is QE. Okay, we can use the electrostatic force here, QE, because the proton move in the electric field. There is a existence of electric field. So F equals to QE and electric field is given. So you can use this, and Q also given. from the proton here, it is understood that the charge of the proton is 1.6 times 10 to the power of negative 19. So you can use that value. E is given, but the problem is the distance. Which distance are we going to use? There are two distances here, 0.4 meter and 0.5 meter. So which one to be used? So remember what is meant by work done, where F dot S means F and S must parallel to each other. So which one is parallel to the force? So for force, we follow the direction of electric field. Okay, so direction of electric field is given this way, so therefore the distance here is 0.5. So E parallel to the distance is 0.5. That's why we choose this equation, this distance, and the answer is 4.8 times 10 to the power of negative 17 joule. Okay, very good. Okay, maybe you can write there together your answer together with the question, so that I can know what your answer is for which question. Okay. Okay, so okay, many got correct answer. B. Okay, very good. So remember, if more can use more than one formula and choose which formula is the suitable one for the given data in the question. Okay, so hi trees at the river. Okay, so can write the number of the question together with the answer so that I can know what your answer is for which question. Okay, so now we go to question 3. Question 3. A certain capacitor consists of a pair of parallel metal plates separated by a distance d in air. So the capacitor is charged, then disconnected from the charging source and immersed in a liquid with a permittivity epsilon. So which of the following statements regarding the capacitor is correct? Okay, so which one? Okay, how to imagine the statement given in the question here. So the capacitor is charged, so it must be connected to the power supply. So the capacitor is charged. Okay, then it is connected and immersed in the liquid. Okay, so you can imagine like this. So immersed in a liquid with permittivity of epsilon. So it doesn't mention here dielectric, but actually it is a dielectric. It is as if dielectric inserted to the capacitor. Okay, so that's mean now from the formula we are going to use is Q equals to CV. Okay, very simple formula. You must memorize it already right now, right? Q equals to CV. So in this Q equation, we have three variables Q, C, V. So which one is constant in this case? Q, C, or V? So if you see the charge flow to the capacitor here, so the capacitor has charge in it, and it is disconnected and the charge cannot go anywhere. Okay, it still remain in the capacitor. So therefore, the charge Q here is constant. Okay, with the initial, this is initial situation. So the charge collected here by the capacitor and the Q remain the same even though we immerse it in the liquid, because it cannot go anywhere. Okay, it still remain in the capacitor. So Q is constant or conserved. Yes, correct. Trees at the river. Okay, so from the formula of C equals to epsilon A per D, so the permittivity of the dielectric here is can use epsilon A per D. So that's mean from air, this is the permittivity initially is air, then it is inserted into or immersed in the liquid, so it has new epsilon naught. Epsilon is epsilon naught epsilon R. So that's mean the C increases. Okay, so epsilon is epsilon naught epsilon R. So the epsilon given in the by the for the liquid here is epsilon. So that's mean the C increases. So when epsilon increases, C increases. So therefore, from the equation here, Q constant and C increases, that's mean the V decreases. Okay, so the answer is C. Okay, the correct answer. Capacitance increase, but the potential difference decrease. Okay, so next we go to question 4. Okay, two identical capacitors K and L. Okay, we have two capacitors here, K and L. So which are connected in parallel to a battery shown here. So when the switch S is open, the potential difference across K is V. Okay, here given as V. Okay, so the charge stored in Q and L is uncharged. The charge stored in Q and L is uncharged. Sorry. Okay, the charge stored in Q, the charge stored is Q, sorry, and L is uncharged. Okay, L is uncharged. So when the switch S is closed, okay, we switch on. So what is the potential difference across L and the charge stored in L? Okay, so we are given that the charge stored is Q. Okay, then we have potential difference across a K here also given is V. So the charge stored is Q. So this is the initial situation. Okay, if the two capacitors here, we can see that they are connected in parallel. So that means the voltage across them is the same. Okay, the voltage across them is the same. So the potential difference across K is V. So that means the V across K also, the V across L also is the same V. Okay, this is therefore C and D is wrong answer. Because given here potential difference half V, they are supposed to be the same because they are arranged in parallel. Okay, so both can you get answer A. So let's see whether your answer is correct or not. Okay, then from Q equals to CV. Okay, so C is Q per V. Okay, for CK, CL also Q per V. So you can substitute the CK into here V because capacitor here is Q per V. So they have same V. So you can substitute into here this CK Q per V into here. Okay, because actually V actually so you can cancel the V and you get the Q. Okay, the charge also Q. Okay, same V, so same Q, right? Same V, same Q. So it's logic lah. And then it's the same identical capacitor. Okay, so it's logic. And from calculation, this is just a calculation to show. Okay, the correct, your answer is A. Okay, now we go to question 5. Okay, 3 resistors. Okay, we have 3 resistors here. Where is it? 3 ohm, 5 ohm, and 8 ohm. And the 3 batteries, EMF 1.5 volt, and then 6 volt and 12 volt. Okay, so the electric potential at point A with respect to point B is, okay, we are going to find the electric potential at point A. Okay, so we can use Kirchhoff law. So we use direct second law because first law, the current is they are all arranged in series, so the current is the same. Okay, all pass through the each of the load resistors. Okay, so we can use second law, Kirchhoff second law, which state that the total of the MF equals to the total of product of IR. Okay, so we for Kirchhoff's second law, we choose a loop. Let's say I choose here clockwise direction, the loop. Okay, and direction of the electric field, electric field by 12 volt is this way from terminal positive, right? Okay, for 1.5 volt, okay, this way from terminal positive, and 6 volt is upward, okay, from terminal positive. So that's the direction of electric field. So therefore we get 12, positive 12, because it's same direction as the loop. So positive, negative 1.5, opposite direction of the loop, minus. And the lastly is 6 volt, opposite direction also, so minus. This is total of MF, 12 minus 1.5 minus 6. And then the product of IR, so they are all in the series. So let's say we choose direction of current this way. Okay, it doesn't matter where you want to choose the current. Okay, lastly, if you got positive or negative, that means the direction for negative, you make it in the opposite direction. Okay, so now let's choose this way, the direction of current. So it's in the same direction as the loop, so they are all positive. So 8I plus 3I plus 5I, okay, all positive because the direction of current is same as the loop, positive. And we calculate, we get I equals to 0.281 ampere. So this current is positive, so it is correct that we choose direction in the clockwise direction because we got positive. So if you choose another direction, you will get negative. Okay, now we get the current. Now let's start to find the electric potential at A. Okay, to find the electric potential, so we find the potential difference first between BA. Okay, so the path you choose, it doesn't matter B to A or A to B. So this is the first step to find the potential difference. So you choose the path, it's up to you, whether B to A or A to B. So let's choose B to A. Okay, B to A, and the direction also is up to you. You can follow this path. So there are two paths you can choose, on top here and passing through down here and up to A. So choose the easiest one. The easiest one will be the up here because we have only EMF. EMF 1.5 volt. Okay, so now the total of EMF along this path is 1.5 volt, and it is negative. Why? Because it's opposite direction of the path. Okay, so negative 1.5 volt. And then we get the total of IR, product of IR. So along this path, we have two resistance, 8 ohm and 3 ohm. And the current flow is the same as direction of the path. Okay, so in this direction. So that's in positive, 8I plus 3I. Okay, so now the potential difference, you calculate 8I plus 3I. The reason we calculate I just now is to find the product of IR. So I is 0.281, substitute into here, so you get 3.091 volt. Okay, now the potential difference is negative 1.5 minus 3.091. Okay, so potential difference means you minus, right? The meanings is difference, so you minus. So negative 1.5 volts minus positive 3.091 volt, so you get negative 4.591 volt. Okay, so this is the potential difference. We don't need the negative sign for potential difference. Actually, it depends on the way you choose, right? B to A, A to B. Okay, so you just take the magnitude 4.591 volt. So now refer to the flow of current. So the flow of the current positive, right? We get, so that's mean it is correct. The flow of current is from point B to A. So that's mean the high potential is at B. So that means starting from here, it should be positive 4.6 volt and end here to negative 4.6 volt because current flow from high potential to low potentials. Okay, so that means the answer is B. Okay, hopefully you understand. Okay, from the flow of current, you see from positive 4.6, okay, at any point along here can be, let's say, positive 0.3 volt, positive 0.2 volt until here positive 1.5 volt. And then for terminal negative here will be negative 1.5 volt, right? Negative 1.5 volt and keep on decreasing, negative 2, negative 3 volt, negative 4. Lastly, at point A will be negative 4.6 volt. Okay, if you think the logic of the flow of current here. Okay, from, remember, current flow from high to low voltage. So that's why the answer is B, negative 4.6 volt. Okay, hopefully you all understand why is it the answer is B. Okay, Wolfgang, why got star there? Not sure for the answer. Okay, so the answer is B. Okay, so now let's go to question 6. Okay, hopefully we managed to cover all the questions because I think our question given is too much. Too many. Okay, now question 6. Find the magnitude of resistance R in the circuit shown below when no current flows through 5 ohm resistor. Okay, no current flows through 5 ohm resistors. So that's mean we can use Wheatstone bridge formula. Okay, from the Wheatstone bridge formula, okay, if there is a galvanometer here, no current flow, galvanometer is set to point to 0. So the ratio P over Q per equals to R over S. Or you can also memorize as P over R equals to Q over S. So it doesn't matter because when you cross multiply here, you still get the same. So to memorize is very easy. Remember that if no current flow through here, so that means we can use Wheatstone-Bridge formula. So in this case, 5 ohm, we can ignore the 5 ohm here because no current flow through it. So you can use Wheatstone-Bridge formula 10 over R per 20 over 10. 20 over 10 and you get R 5 ohm. Okay, very simple. So just the problem, most of you all, the problem is the formula, to memorize the formula. Okay, so now we go to question 7. Okay, question 7. 4 wires in a horizontal plane each carry a current I is shown in the diagram below. Okay, they cross each other without touching to form a square. Okay, without touching. Point P is at the center of the square. Okay, the magnetic flux density at P due to one wire only is B. So means each of them provide magnetic flux density B. So what is the strength and direction of the magnetic field at P due to all 4 wires? Okay, so what to do? You can use grip rule. Okay, okay, Wolfgang. So if the current arranged differently, how do we recognize it if it is using Wheatstone-Bridge formula? Okay, the arrangement must be in the given just now. Okay, and actually use, okay, when this the confuse is because you don't know the equivalent circuit actually. So there are the question may be given in not different way of arrangement of wire, arrangement of resistor, but actually the equivalent arrangement only. Okay, so if other arrangement is given, make sure it is equivalent to the just now given. Okay, look, we go back. So it can arrange like this, or it can arrange in the equivalent circuit. Okay, you can refer to at any notes. Okay, or I can post it later to you. Okay, so just can contact me later. I will show you a few example of equivalent circuit. Okay, equivalent circuit to the Wheatstone-Bridge circuit. Okay, Wolfgang. Okay, now we go to question 7. Back to question 7. Okay, just now what? Okay, we use grip rule. Okay, grip the rule, and you. Okay, Wolfgang. Okay, now the 4 fingers here. Okay, the direction of the 4 fingers is into the screen. So we use the symbol cross here to represent the direction of the magnetic field into the screen. Cross. So we do the same for wire I. For this wire grip. So also into the screen, and wire I we grip also into the screen. But lastly, wire I is out of the screen. Look your finger there. If you grip the wire here, okay. Remember the thumb shows direction of current, right? So it's out of the screen. So that's mean 3 and 1. 3 and 1. So let's say we choose the resultant, the direction of cross into the screen is negative, and then the out of the screen is plus. So that's still negative 3B plus B, you get negative 2B. So this negative we define as into the screen, right? So the answer is into the screen. In this case is into the page lah. If your exam paper, into the page. So 2B into the page. So when we write into the page, we no longer put negative there. Because this negative just represent the direction is direction of the B is into the page. Okay, so hope you all understand. Okay, those the answer for 7 is D. Yes, Chaya. Okay, now we go to question 8. Okay, negative Y Okay, because Priya, we choose the direction into the screen as negative. If we choose direction of into the screen as positive, you still get the same answer. Now we choose direction of into the screen as negative. So negative 3b, we have 3b into plus b. Outward is positive, right? Or out of the screen. So we get negative 3 plus 1. Negative 3 plus 1 is negative 2b. So the answer negative as we defined earlier is into the page. Okay, into the page. So that's why the answer is into the page. Okay, not Priya? Okay. Okay, so we go to question. Next question. Okay, number 8. A circular conducting loop is connected to a battery and a switch S as shown in the diagram below. Okay, so immediately after S is closed, the current through the loop changes at a rate 15 ampere per second, and the EMF induced in the loop has a magnitude of 5 volt. So what is the self-inductance of the loop? Okay, so you are given di by dt and the EMF. So self-inductance is L. So by listing, by labeling at the question, you can see that the formula that we're going to use is EMF equals to negative L di by dt. So we just want the magnitude, right? So no need negative. So EMF equals to L di by dt. Okay, so rearrange the equation here. You get EMF per di by dt and substitute the 5 volts and 15. We get 0.33 Henry. So be careful with the question because I found that my student also answer wrongly here, but because of careless mistake, the reading here 3, right? Answer A instead of C. So the answer is C. So be careful. So 0.33 Henry in the standard form is 3.3 times 10 to the power of negative 1 Henry. So be careful with the common mistake in this standard form. Okay, now we go to question 9. Okay, question 9. A pure resistor is connected to an AC source with its current supply I equals to 4 sine 6 to 8 T flows in the circuit. So which statement is not true about the circuit? Okay, so you compare this equation, okay, of current, because this is AC circuit. So the I general equation is I equals to I naught sine omega T. Okay, so you compare, so that's mean the 4.00 here is the I peak. Okay, so question B is true because the question 1 is not true. Okay, so the peak of the current is 4 ampere, peak current 4 ampere. And then from the IRMS, to find IRMS, you use I peak per cert 2. So you substitute into here the 4 ampere, so you get 2.8 ampere. So that's mean A is true. The question 1 not true, be careful. And the 6 to 8 T is angular frequency, okay, omega angular frequency. So that's mean you can find frequency is 100 hertz. Omega angular frequency is 2 pi f. So you get F frequency 100 hertz. So that's mean the C also true and D is not true, because 6 to 8, this is 6 to 8 is for the frequency, for the angular frequency. So the answer is D, not true. Okay, so I think we can take a break, okay, for a few 1 minute. So see you next in 1 minute time. Okay, let's take a break with the iklan, okay, advertisement.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, hi, welcome back students. Okay, we continue with the section B part. Section B, question 10. Okay, so let's read the question. A positively charged sphere C is near a long insulated conductor AB. Okay, draw sketches to show how the potential V all around C varies with the distance from C measured along AB and beyond, before and after AB is placed in position. Okay, so that's mean the questions once V varies with the distance. So that's mean the graph V against X. Okay, not the magnetic field. So don't get confused about this question. The questions doesn't want magnetic field. So the questions one, how V potential V varies with X. Okay, so now before AB is put before AB is put near the C. Sorry. So electric potential V inside the sorry, I need to take a drink. Okay. Okay, so this is a sphere. Doesn't mention here is a metal, but we suppose the question is to say the metal. Okay, if the question for your level also you learn about metal charge. For metal, the charge will repel each other, so it will accumulate on the surface of the metal. So that's mean inside there is no charge there. But therefore the electric field is zero, but the potential V is constant. Okay, potential V is constant. So you draw like this, and then as it the distance further from the C, so what happened? The electric potential decreasing. Okay, from the formula Q per 4 pi epsilon naught R. Okay. So now if we put AB, what happened? So if we put is conductor here, initially this conductor is neutral, not charged. So that's mean the charge will separate into two. So the negative will go near the will be attracted to the positive sphere charge just now. This sphere charge. So negative will gather here. So the other side will be positive. So in the middle, the electric potential again is a constant. So you put here the constant. So continue from here, then in between is decreasing, the potential decreasing, and then in between AB is constant, and then it's further away from the charge, spherical charge here, so it's decreasing. So the green line, solid line is for the question A2. Okay. Okay, so now we go to question B. Question B, an alpha particle A of charge positive 3.2 times 10 to the power of negative 19 coulomb and mass 6.8 times 10 to the power of negative 27 kilogram is travelling with a velocity of 1 times 10 to the power of 7 meter per second directly towards a nitrogen nucleus. So this nitrogen nucleus, this is the alpha particle. The charge is 11.2 times 10 to the power of negative 19. So charge for A is given and also given. So calculate the closest distance of approach of A to N, assuming that A is initially a very long way. There's a reason mentioned why it's a very long way from N. So compared with the closest distance of approach. So the closest distance of approach means that you see A is positive and N is positively charged. So they repel each other. So the nearest they can go for the repulsion force we must consider this as repulsion force. So it still can go with this speed, but how near it is, how closest the distance it can go. Okay, so now it start from the very long way. So if from the very long way, it is understood that the potential at a very long distance is negative. is zero. So is zero. The potential at the infinity. You can say that this is at infinity, a very long way. So that means the potential at this long distance is zero. Whereas the potential near where A and B can go near as far as possible is the highest. And what about the kinetic energy? So the kinetic energy will be zero here because it come to the stop. Okay, it can no longer go nearer to M. So that means the kinetic energy becomes zero. And from initial, the V speed is given. So that means it have the initial kinetic energy has half mv squared. So in this case, we use a concept principle of conservation of energy. Okay, so the concept physics we use here is principle of conservation of energy. Okay, so let's start now from the principle of conservation of energy. So we label what is given so that we reduce our careless mistake. So this is mass, this is Q1, this is Q2, and this is V, the speed. So from principle of conservation of energy, so change in kinetic energy is equals change in potential energy. So how we get this? Remember the SEM 1 we've learned. Okay, from the principle of conservation of energy, it state that total of energy initial equals to total of energy at the final. Okay, so I label it as Ki plus Ui equals to Kf plus Uf. So when you rearrange the U together, put one side, kinetic energy to one side, you will get change in potential energy and change in kinetic energy. So also you can arrange like this. So it's up to you. Both is correct. Okay, so now the change in kinetic energy will be half mv squared. Okay, we know that when it come near to the when it come to the stop, where it is the nearest position and approach the end, so half mv squared minus 0, so it's half mv squared. So for the delta U is change in potential energy, so we use electrostatic energy, potential energy, which is formula is Q1 Q2 per 4 pi epsilon naught R. Okay, Q1 Q2 per 4 pi epsilon naught R. So also minus 0, infinity is 0. So nearest here is the highest. Okay, so now we equate them and substitute every value given. Leaving only, okay, what the questions want, closest distance, right? So that's mean the R, the R. Okay, so now we cross multiply. Okay, we get 9.5 times 10 to the power of negative 15 meter. Okay, not? So those who've done this question, did you get the answer? Okay, so this is the answer. Okay, any problem you can ask there in the chat box. Okay, so now we go to the next question. Okay, next question is about potentiometer. Okay, so we read together the question. In the circuit diagram shown, the length of the slide is 100 centimeter and its resistance is 8 ohm. R1 and R2 are 5 ohm and 50 ohm respectively. E is the accumulator, okay, of MF 2 volt. So negligible internal resistance. Okay, no internal resistance. When both the switches S1 and S2 are open, the galvanometer G is balanced when the length AJ is 72 centimeter. Okay, so this is the first information. The second information, when both S1 and S2 are closed, the balance length AJ is 15 centimeter. So this is the second information given. So got two informations given. Okay, so we label everything given data given in the question in the diagram so that we don't make careless mistake. Okay, so this is 100, the wire AB 100 centimeter, resistance 8 ohm, R2 15 ohm, R1 5 ohm, and E 2 volt, no internal resistance. Okay, so now to find the MF of E1, so there are two information given. So which one to be used? So you must understand which one to be which information to be used to find E1. Okay, to find E1, this is the outer circuit, this is a potentiometer circuit. So to find E1, so we must open the S1. We must open the S1 because if we close S1, so that's mean E1 has internal resistance. It doesn't mention here E1 has internal resistance. So that's mean to be safe, we just open it so that we just take into account using potential divider formula, just E1 as a potential across AJ. Potential across AJ is equals to E1. Okay, so we can use potential divider formula, and then information is this one because S1 and S2 open. Okay, S1 and S2 open. So S1 must open. So we choose the first information. Okay, now we can forget about the R1 just now, R1 because it's open. So it's not used in our calculation later. The information not used in our formula used for potential divider. So you can, I erase this for that you can understand me that we don't use this value. Okay, so from the potential divider formula, okay, potential across AJ is potential difference across AJ is equals to E1. So that is E1. What we are going to find, okay, E1. So potential difference across AJ is E1, and potential difference across AJ also equals to the AJ over AB times the V across AB. Okay, potential difference across AB. So this is another potential divider we use. Okay, AJ per AB times the voltage across AB. So AJ is given here 72, and then AB also given 100 centimeter. So you can substitute 72 per 100 into here. Okay, what about AV, voltage across AB? So voltage across AB, we cannot use voltage across AB. We cannot use 2 volt. Okay, we cannot use 2 volt because we have this resistance. So we can use a potential divider formula again here. Okay, and switch R just now open, right? So S2. What is the name of S2? So S2 is open. So we can ignore this S2. So it just R2 here. So there are 2 resistance in the potentiometer, resistance 8 ohm and 15 ohm. So you can use a potential divider formula, 8 per total of 8 plus 15 resistance, total of resistance times the 2 volt. So you cannot get it, substitute 2 directly because of the R2, because of the R2 here. Okay, if you can remember, I draw here the potential divider formula. Okay, V across R1, we use R1 per total of R1 plus R2 times E. So in this potentiometer, okay, we have 8 ohm and 15 ohm. So that's why we use potential divider formula in VAB here. Okay, not? So it's 8 per 8 plus 15 times 2. Okay, so now we go to the answer is 0.501 volt. So this is the answer. Okay, negative 0.501 volt. Okay, so got problem or not? Okay, if no problem, we go to question B. Question B, to find the internal resistance of the cell E. Okay, to find the internal resistance of cell E, so now we are going to use the second information. So we are going to R must take into account in the potential across here. Okay, AJ. So that's mean we need to switch to switch off to switch on the S1. So that this will become the closed circuit. This is a closed circuit. This is not open circuit. Now this will become a closed circuit. So we need to use the second information given by the question. S1, S2 close. The AJ is 15 centimeter. So S2 also close. S1 also close. Both close. So if both close, so that's mean, this is the second information given. So the potential across AJ, potential difference across AJ, okay, is equals to the potential difference across R1 or across E1 with the internal resistance R. Okay, with the internal resistance R. So you can choose either one, but choose the easier one. The easier one will be across R1. You can also use across E1 with internal resistance R. Okay, but it's a longer method. It's a longer method. So choose the short method. R1 where we can use this potential divider equation. So R1 will be potential electric potential potential difference across AJ will be 5 per total of 5 plus R internal resistance 5 per 5 plus R times E1. Okay, refer to this circuit, equivalent circuit. This is the R and R1 is this one. Okay, and the potential difference across R1 will be R1 per R1 plus R here, 5 is R1 times the E1 here. Okay, so now for E1 you substitute because calculated already in A, so you can substitute into here. Okay, then for the potentiometer part, potential difference across AJ will be AJ per AB, which is 15 per 100. Then the E. Okay, the E here you can directly substitute 2. Okay, why? Because this is S2 is closed. When S2 closed, it seems like R2 is not in use because it is short circuit. The wire here is short circuit. Okay, so the wire here is short circuit, so we don't take R2 into account. So the E is directly can use 2 volt. So no resistor here. So if you use potential divider here, it is like 8 over 8 times E. This is 8 ohm, right? 8 over 8 times E. So the ratio is to itself, 8 over 8. So not 8 over 8 plus what is R2 just now? 15, right? So it's not that formula used because no resistor here. So directly can put 2. Okay, so now we can find R. The rest is all the mathematics. Calculate using the mathematical operation. So R equals to 3.35 ohm. So that is our answer. Okay, 3.35 ohm. Okay, so done for B. Okay, now we go to C. The balance length AJ when S1 is open and S2 is closed. Okay, so you know R and you know E1, so you can find C. C, S1 open. This one open, S1 close, S2 close. This one close. So if this one close, you can forget R2 because this is a short circuit. Short circuit. So forget about R2. And then if S1 is open, so you can forget about R1. Very simple. Forget about R1 because S1 open. So the voltage across AJ here will be equals to E1. Not involve R. So straight away E1 because it's open circuit here. Just E1 in the circuit here. So it's open circuit. So can equate to E1. And from the potentiometer, the potential difference across AJ will be AJ per AB. Okay, AJ per AB is we are going to find AJ. So AJ per 100 times the VAB. So VAB is 2 because this is short circuit. Short circuit wire. So S2, no resistance here. And you get AJ 25.1 centimeter. Okay, so that's the answer. So now everyone keep quiet. Hopefully you all understand. Just write there in the chat box that you are with me now. Okay, now we go to question D. Question D, the balance length AJ when S1 close and S2 open. So S1 close. Okay, S1 close and then S2 open. This one open. So if this one open, S1 close. So digesting, Wolfgang. Okay, so it's okay. You can still refer to the YouTube. I record this. This is a recording, YouTube. So you can refer later. Okay. Hopefully, I'm not explaining too fast. You can follow our session. Okay. So now let's go back to question D. So S1 close. So this is a closed circuit now. A closed circuit. S2 open. So S2 open. So that means R2, the current flow to R2 now. It's not a short circuit. So the current flow to R2. Okay, so for the voltage across AJ from this closed circuit, so we can use the potential divider formula. So we take R1 5 per 5 plus 3.5. Internal resistance calculated already just now. So you can substitute into here. 5 per 5 plus 3.31. So R and R1 is, if you draw the equivalent circuit, is like this. Okay. R2 will be R, 5 ohm will be R1. Okay. So 5 per 5 plus 3.5 times the 0.501. Okay, so for the potentiometer circuit, okay, so what is the potential divider formula looks like? Okay, so it's AJ per 100. AJ is what we're going to find, right? So AJ per 100. And then the voltage across AB is not 2 volt. Okay, you cannot substitute 2 volt here because we have R2 in the potentiometer circuit. So imagine this is R2 15 ohm and this is 8 ohm R1. So we use this equation. So it will be 8 per 8 plus 15 ohm. Okay, times the EMF here 2 volt. Okay, so the answer for AJ is 43.1 centimeter. So this is the answer. Okay, very simple actually. So as a conclusion, okay, I make the conclusion here. This is a potentiometer. Okay, where what is the main use of potentiometer? The main use of potentiometer is to measure the potential difference across these 2 points. So if we put open circuit here, okay, so like which one? This one or this one? Okay, so the formula will be E1 equals to AJ per AB. So AJ per AB times, so there is R2 there. So you must use RAB per RAB plus R2. RAB per RAB plus R2 times the EMF here. Okay, so it's like potential divider into potential divider. Double the potential divider formula. The AJ per AB times the voltage here also is come from the potential divider formula. Okay, only that we use length because length is directly proportional to the resistance in the formula repla. Can you remember now? R equals to rho L per A. Okay, so if the here we connect to the open circuit, this one, but with no resistance there. No resistance. Can see or not the difference between these two? So the formula will be E1 equals to AJ per AB times E here. Direct E. Because the potentiometer only consists of AB, one resistance on the AB, wire AB. Okay, now for the, if the 2 points here is attached to the closed circuit. This is a closed circuit. What is meant by closed circuit? Closed circuit means there's a current flow. Here no current flow. So here got current flow. So it's a closed circuit. So for the closed circuit like this one, if no resistor there, okay, so you use for the closed circuit is R1 per R1 plus R. It got internal resistance R1 per R1 plus R times E1. And from the potentiometer is AJ per AB times E. Okay, and if there is a resistance there in the potentiometer, so R1 for the closed circuit here, R1 per R1 plus R times E1, and for the potentiometer circuits will be AJ per AB times R ratio of RAB to total of RAB plus R2 times E. So this is the 4 possible arrangement of potentiometer with the outer circuit, either is open circuit or closed circuit. So just use the potential divider formula, all because of potential divider formula, then it's very easy to solve. Okay, so now we go to the next question. Question 12, but question 12 I'm going to skip the 12A and B because we almost not enough time. So we go to question C, the calculation part. Okay, calculate the resistance per unit length of a 22 gauge nichrome wire of radius 0.321 millimeter. Resistivity of a nichrome is 1.5 times 10 to the power of negative 6 ohm meter. So if a potential difference of 10 volt is maintained across a 1 meter length of the nichrome wire, so what is the current in wire? Okay, so the wire is melted down and recast with twice its original length. So find the new resistance Rn as a multiple of the old resistance R naught. Okay, so now we do question 1. Okay, the given is resistance per unit length. So you can use formula repla. R equals to rho L per A. Okay, I love to memorize this as repla. Okay, R equals to rho L per A. Resistance per unit length, so that's mean R per L. Okay, so rho L also per L, so cancel out, or another way, let L bring to the left side. Okay, R per L equals to rho per A. Okay, so area, you can assume that the cross-sectional area of the wire is equals to the area of a circle, so pi R squared. Okay, now substitute everything. The radius 0.31 millimeter, convert to meter. Resistivity is 1.5 times 10 to the power of negative 16. Don't forget squared, so we get 4.6 ohm per meter. Remember the problems here, if student put unit as ohm only. The question asks for what? The current in the wire. What is the current? Okay, the question asks for current in the wire. Okay, sorry, the question asks for resistance per unit length. So resistance per unit length, so the unit should be ohm per meter. So many make mistake here. Even my students just put ohm only. Whereas the questions one, resistance per unit length. So the unit should be ohm per meter. Be careful with the question. Okay, now we go to yes, trees at the river. Priya, okay, resistance per unit length. Resistance per unit length. So must use repla. Okay, because given here resistivity, so use repla. Okay, so we keep this answer here. Okay, this is our resistance per unit length. Okay, then question 1. Question 1, if a potential difference of 10 volt is maintained across 1 meter length, so of the nichrome wire, so what is the current in the wire? Okay, so we use V equals to IR because voltage is given. We want current, so V equals to IR, but the questions want potential difference maintained across 1 meter per length. So that's mean V per L, R also per L. Okay, we don't change the equation, right? If you per L both side, same length also, we can cancel out. We don't change the equation. So V per L equals to IR per L. Okay, so now we can substitute this R per L. So it's 4.6 ohm per meter. Okay, so now the current is 2.2 ampere. So this is voltage per 1 meter. Can see or not the relationship between question the first top here to question 1. Okay, so the answer is 2.2 ampere. Okay, the current for the wire. Okay, now we put here. Now we go to number 2. Number 2 is the problem. I give this question to my student and many cannot answer this question. Okay, so the wire is melted down and recast with twice its original length. So find the new resistance Rn. So you must use this symbol Rn, cannot use other symbol given the question. So you must use what is given in the question. Yes, the length is cancelled. So because V per L, R per L. Okay, R per L is this one already, right? Just now. Okay, go back. Okay, so this is R per L. You see, you substitute R per L. And then you substitute voltage also per L, per 1 meter. This is 4.6 ohm per 1 meter. Actually, per meter means per 1 meter. Okay? Okay. Happy that you can understand. Okay, now we go to 2. Okay, so we use formula reply again. Okay, so we use the what given in the question, R naught. So we use R naught. So substitute R as R naught because we are going to answer in terms of R naught. In terms of R naught. So follow what question asks. Okay, so R naught equals to rho L A naught. A naught, this is the initial cross sectional area. Okay, so then the second one is Rn. So you use Rn equals to rho. L is double. Okay, so 2L divided by area will change because you melt it down and then you recast it to twice its original length. So logically, the A here area, cross-section area, is not the same as the initial. So that's why we name it as AN for the area. So it's no longer the same. So this is our problem now, to find area AN. So A naught is not equals to the AN, A initial or A final. Okay, to find AN, we use concept volume is the same. So you melt the wire with the same volume, right? The wire you melt it, so the volume maintain the same. So V naught equals to Vn. So V naught will be, we use a cross-sectional area times the length of the wire. So A naught times L naught, the length of the wire, and An equals to 2L naught because it's I put here 2L, right? 2L also can, 2L naught also can. Better put L because initially I put all L. Okay, so L naught here 2L naught. Understand or not? Volume is constant, but the length is changed to L naught, and A also change. Cross-section area also change. So now we can cancel N naught, L naught. So we get area becomes half, half of the N naught. Okay. If you can imagine it, can you imagine? You melt the wire and you form the new wire, so surely the cross-sectional area won't be the same anymore. Okay, using this relationship, okay, so it's become half N naught. So now you can substitute here half N naught. So now you can use simultaneous equation, substitute the first one into here. Okay, so draw L per N naught here and 2 per half. So this one is R naught. Okay, from the R naught here, any method you can use actually. So which one is the faster one, or you master? Actually, you can master you should master many method because you are from upper 6 already. Okay, so bring this up, so you get 4 R naught. So that's our answer. Answer in the form as a multiple of all resistant or initial resistant. So the answer is 4 R naught. Okay, yes, I must show the AN working. Okay, got mark here. Okay, this is one set, 1 mark. Okay, so sometimes 2 or 3 step working considered as 1 mark. So must show everything, whatever you know in the exam. You just write down there. You just write. Okay, so we go to the question 13. Okay, question 13. Define magnetic flux density B of a magnetic field. Okay, then the second question. We define first. Okay, we define. You can use equation here, but make sure you define each of the variable used. So F is force on charge. V is speed of charge. Theta is acute angle between B and B. So you must mention acute angle because theta can be in another way direction. So theta is supposed to be acute angle between B and B. Okay, so magnetic flux. Many students confused with the magnetic flux density and magnetic flux. So the two magnetic flux and magnetic flux density is two different quantity, physical quantity. Two different physical quantity. So magnetic flux density is equals to magnetic field strength. Some books use magnetic field strength. Some books use magnetic flux density. Actually, they are both B. B. So why it is state as magnetic flux density? Because from the magnetic flux B dot A, so B is magnetic flux per A, so that's why B is called magnetic flux density. Okay, from the here, so that's why B sometimes is said as magnetic flux density. So this is why B is also state as magnetic flux density. Okay, so or you can write in a statement like this: B is the force on a charge of 1 coulomb moving with a velocity of 1 meter per second at right angles to the magnetic field. Okay, or you can use this formula instead. If a straight wire, magnetic field around 8 wire, around a straight wire, so you can use B equals to F per IL sin theta. Okay, also can for definition of magnetic flux density. Okay, so now we go to question 2, A2. A long straight wire X carrying a current 2 ampere is placed parallel to the shorter wire of length 0.05 meter carrying a current of 3 ampere. So as shown below, two wires are separated by a distance of 0.10 meter. So the distance is 0.10 meter. So determine the magnetic flux density B at Y due to X. So at Y, so this wire, so be careful of the current you use. You are given two current here, 2 ampere, 3 ampere. So be careful. So we are going to determine B at Y, B at Y at this point. So that means the wire Y here experience a magnetic field by wire X. So when you use grip rule, so the direction of the magnetic field by this wire X on wire Y will be tangent to the circle here, which is in this direction. Okay, the questions ask for B at Y. So the formula for a straight wire, B for a straight wire is mu naught I per 2 pi D. So you must memorize the formula for B of a straight wire, B of a coil, and B of a solenoid. Okay, so by right now you must memorize already, right? Next week going to be exam. Okay, so for a straight wire is B equals to mu naught I per 2 pi D. So this is where I mentioned just now, I must be very careful. This I is which one, 2 ampere or 3 ampere? So if you straight away to the formula, not understand what the questions want, so you are, you will be careless mistake substituting as 3 ampere. So you must really understand where the B comes from. The B comes from wire X, so therefore the I must use 2 ampere. Okay or not? Common mistake student makes every year because of this I. Okay, so now mu naught is 4 pi times 10 to the power of negative 7 per 2 pi. Distance is 0.10. So the answer is 4 times 10 to the power of negative 6 Tesla. 1 hour talking already. I need a cup, a sip of water. Sorry. Okay, so that is BX. Okay, so now we go to the question B1, state Faraday's law and Lenz's law. Okay, this one I think I can go very fast because you can get it from your books. Okay, the statement for Faraday's law and Lenz's law. Okay, we can skip this. We go to B2, derive an equation for the induced MF in a linear conductor at right angle to a uniform magnetic field. Okay, so for formula, we start with the definition of magnetic flux. Magnetic flux is B dot A. The dot there must highlight the dot. Don't just write BA. So when it's right angle, so then also the dot no longer to be write down, because this is magnitude already. This is definition. Okay, this is a magnitude. Right angle is sine 90, right? Sine 90, so 1. Okay, B and A must parallel to each other, and direction of A is normal to the surface. Okay, so as a conclusion, B and A is parallel to each other. Okay, so now B times A. So A is a linear conductor, so you can imagine like this. This is a wire, so it moved to X distance. So that means the area covered by this straight wire is L times X. Okay, L times X, area of a rectangle. Okay, then substitute into the Faraday's law, EMF equals to negative d phi by dt. Faraday's and Lenz's law together because got negative there, right? So substitute BLX into the equation here. And BL is constant, so use derivation rule, okay, or differentiation rule. So BL bring to the front, X is changed, right, because it moved with distance X, so X changed, so dx by dt. And dx by dt will give you V, okay, speed. So that's therefore the formula for the induced MF in a linear conductor will be E equals to negative BLV. Okay, so derive. So we derived the equation already. So this is the answer. Okay, so now we go to the 13C. Okay, 13C. Last one question 13. Okay, the figure below shows a strip of metal 6.5 centimeter with 0.85 centimeter and thickness 0.76 millimeter. So usually if you are given thickness, it's something to do with the hall voltage. That's a clue. Okay, got thickness, maybe something to do with the hall voltage. Okay, so let's read. So continue reading the question. The strip moves with constant speed through a magnetic field B of 1.2 millitesla. Direction of B is perpendicular to the plane of the strip. So a potential difference of 3.9 microvolt is produced from P to Q. Okay, P to Q. So you can know why P to Q by using the Fleming's right hand rule. Okay, remember right hand rule because MF is induced. Okay, produce, induce. So that's mean right hand rule. Be careful to use which one, like right hand rule or left hand rule. Okay, so it is correct that the EMF is from P to Q. Okay, so your thumb shows right, the velocity V, and then the cross into the screen, your B into the screen, your middle, your forefinger, and your middle finger shown to the direction of current induced or EMF induced. Current induced this way, but EMF induced P will be positive, Q will be negative because current flow this way. Okay, so correct lah. What is mentioned in the question, this one, P to Q. Okay, now determine the speed of the strip V. So we use the formula just now, EMF equals to negative BLV. So substitute the EMF, okay, 3.9 microvolt, convert to volt. B is 1.2 times 10 to the power negative 3. And then L 0.85 centimeter. And then the speed V. Speed V. So you get 3.82 times 10 to the power of negative 1 meter per second per second. Okay, so that's the answer. So and 0.85, be careful, which one you must use, 6.5 or 0.85. Okay, you must choose the one that means perpendicular to the what you call this, magnetic field. So this the width of the metal strip. Okay, 0.85, not the length. Not the length. Okay, so now we put this here and we go to next question. Now current 2 ampere is allowed to flow in the strip. Okay, there's now got current here. Got current and it's the same direction as the speed V of the strip. So it is found that the potential difference across PQ is eliminated. So explain why this happened and calculate the number of free electron per unit volume and in the metal strip. Okay, so if thickness given, what is in your mind? Automatically in your mind, there must be hall voltage involved. Okay, so how to do? Okay, so you use, there is now a current flow. If there is a current flow, so that means you must use Fleming's left hand rule to determine the direction of current. The direction of the force by the flow electron that flow through the current here, experienced by the electron. So you use Fleming's left hand rule. Okay, so thumb here shows the direction of B, and then your middle finger shows direction of the current. Stated here same direction as the speed, so means upward, the speed is upward. Okay, so therefore the force is to the right, to the left. Okay, to the left. Okay, to the left, this way lah, follow the picture. Okay, this way. So that's mean the electron all gather at left side of the strip. Okay, remember current is a flow of electron. So because of this force, all electron gather here at left side of the strip. So therefore the other side will be positive. Okay, not? So can you see? They are opposite, opposite direction. If the strip move towards the B here, so the MF induced is here, positive, negative. But when the current flow here, the MF induced will be opposite. So therefore, it eliminates each other. Okay. So if a current I flow the direction of V, so the conduction electron move in the opposite direction. So therefore, hall voltage produced. You must mention the hall voltage. Okay, hall voltage will be produced across PQ. This time Q positive. You must mention Q positive, P negative. Given in the question just now, P positive, Q negative. But because of the hall voltage, Q positive, P negative. Okay, yeah, the label with the blue, blue, positive, negative, blue. Okay, so if this hall voltage is equals to 3.9 microvolts, okay, then the potential difference V across PQ will be eliminated. So you must mention this because here, the question stated here is eliminated. So you must mention that it's equals to 3.9 microvolt. This is the induced. This is from hall voltage. Okay? So if they are equal, so therefore the potential difference across PQ will be eliminated. Then you get full full mark. Okay, nah? Yes, trees at the river, hall voltage. Okay, but to get full marks, you have to answer all these. Okay. Now to calculate the number of free electron per unit volume, so you use BNET formula. Hall voltage equals to BI per NET. Okay, so do you all memorize already this formula? Okay, so for hall voltage is 3.9 times 10 to the power of negative 6 equals to 1.2 times 10 to the power of negative 3 Tesla. I is 2. N is what we are going to find, electron charge, and then the thickness is 0.76 millimeter, convert to meter. So N is 5.06 times 10 to the power of negative 24 per meter cube. Okay, that's our last question. For question 14, if I have free time, I will make it as a video. Okay. Okay, so I think that's all for today. Okay, thank you you all for watching, and the before I end, okay, I would like to announce the third, fourth, and fifth digit code for the credit claim. Okay, so it's 386. Okay, 3, 8, and 6. Okay, hopefully you all can score lah. I pray you all can get colorful result. Okay, especially in physics. Okay, so with God's grace, we have reached the end of today's lesson. Sorry, and congratulations to those who are able to follow the lesson from the beginning until the end. Okay, and please stop posting all your comments for a while and click the subscribe button. Those who haven't subscribed my channel, so please subscribe, okay, and activate the icon bell so that you will not miss the next class lesson. Okay, next class lesson will be SEM 3 lah, and SEM 1 also. I will alternately lah with my partner, Madam Nun. Okay, and then I will put the link of the certificate and credit claim link in the chat box. Okay. Okay, there is the certificate link, and then link credit claim. Okay, and then my username. Okay, so the link will end half an hour after this live, so make sure to use the EDD email and more email to log in. And then if you wish to get more information on the online classes, go to the www.academyyoutuber.com. And once again, I would like to thank all of the students for joining today. Okay, you are awesome, and feel free to share this free tuition class to your friends and teachers, because this is the collective effort from all teachers throughout Malaysia, okay, and also to all students throughout the country. Okay, and thank you for being a YouTuber Academy supporter too. Okay, so I think stay all for now. Good luck, okay, for your exam in SEM 2 next week. So see you in another lesson. Remember the hashtag bermula percuma and selamanya percuma. And Assalamualaikum. Stay safe till we meet again next week on Sunday at 5 p.m. Okay, so bye-bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.